Hello and welcome. We are discussing PYQs of number system and we will continue with our theme of abstract cases. We have solved few problems already. Let's continue with the next one. So this is a problem that was there in the year 2023. It says D is a 3-digit number such that the ratio of number to the sum of its digits is least. So let's say the 3-digit number is ABC. Let's say the 3-digit number is ABC, where A is the 100th digit, B is the 10th digit, and C is the units digit. Now we are looking for a ratio of this number with sum of its digit. Is least. I want this ratio to be least. This is possible when this sum or the denominator is maximum and the number is minimum, right? So I have to think of a number which is minimum at the same time sum of its digit is maximum. So if you want your number to be minimum, then definitely the value of A, its 100th digit must be 1. If you want the minimum value of a 3-digit number, then its 100th digit must be 1. So value of A is 1. Now at the same time, if you want the sum of digits to be maximum, then the remaining digits must be the highest possible. So in this way you will find out the number is 199 and this is the minimum 3-digit number whose sum of digit is maximum. And if you calculate this ratio will comes out to be the least one. What we are looking for finally? The difference between the digit at 100th place and the digit at units place of D. So digit at 100th place is 1 and digit at units place is 9. So difference is 9 minus 1, which is 8. Hence answer is option C. I hope class this question is clear. Let's move on to the next one. The next question is this. It says if x minus y is equals to 8, then which of the following must be true? So statement number 1 says both x and y must be positive for any value of x and y. So guys, we have discussed a similar kind of question already, and I have told you whenever a statement has word like definite or must, in those cases we just have to find out one such condition which will negate the statement. Over here it says both x and y must be positive. Now I have to think such value of x and such value of y. If I subtract them, my answer should be positive 8, and at the same time the assumed value will negate my statement 1. So see, so if I assume x to be 8 and y to be just a second, x to be minus 8 and y to be minus 16. See, in this assumption, my x is negative, my y is also negative. But this assumption is still validating my given equation. See, minus 8 plus 16 is positive 8. Hence, statement 1 is not true. I hope the point is clear. Let's move on to the next. It says if x is positive, then y must be negative. Now over here must be written. So we have to find out one such assumption which will be just opposite of this given thing, okay, and will justify my given condition. So over here the examiner is saying y must be negative, so I'll find out a value of y that is positive so that I can negate this thing easily. Okay, so see, x is positive, then y must be negative for any value of x and y. So x is positive, so let's say x is 16, and y is positive also, so let's say y is 8. So 16 minus 8 is giving me 8. So for positive value of x as well as positive value of y, my given condition is justifying, which makes my statement number 2 a wrong statement again. Okay, now see, over here must is written, so I am looking for only one such assumption which will negate my given statement. Okay, let's move on to the next case. On the final statement, it says if x is negative, it is saying if x is negative, then y must be positive. Y must be positive. So I'll try to find out if x is negative and y taking y negative also, is this equation is valid? Because if it becomes a valid, it will negate my statement. Okay, why I am focusing more on negating the statement? Because over here must is written. So x is negative, y must be positive. So see, x is negative, so let's say x is minus 8, y must be positive, so let's say y is minus 16. Done. So see, if x, right now my x is negative, but for negative value of y, the given condition is still justifying, hence statement 3 is also wrong. So the right choice should be option D, neither 1 nor 2 nor 3. Let's move on to the next